Okay, so this lesson will really wrap up everything we've learned up to this point. We've talked about radians, we've talked about points and angles on the unit circle, we've talked about coterminal angles, negative angles, those things. We've talked about how sine, cosine, tangent, and their reciprocal functions have all tied into the unit circle, and this is the reason why, because we want to be able to use all that information to evaluate anything that we come across. So I've included a few problems here. I think I may even change some of these because some of them kind of seem redundant. So for instance, let's just look at, instead of cosecant of negative pi over 4, let's look at just cosine of negative pi over 4. And we'll look at that. So these are all things that I would include on a quiz for the unit circle. But suppose, for instance, we want to know cosine of negative pi over 4, just to illustrate how this works. A simple way to do this, I usually draw a circle. I know positive pi over 4 is 45 degrees in a counterclockwise motion, so negative pi over 4 would be 45 degrees in the clockwise motion. That's negative pi over 4, that angle. I know from review and from previous lessons that that point, and I probably wouldn't write it down normally, but I do know that that point's the square root of 2 over 2 and negative root 2 over 2. Cosine value is the x value, so the cosine of negative pi over 4 is simply square root of 2 over 2. In the next problem, secant of 7 pi over 6. First thing I'm going to think is, where is 7 pi over 6? 6 pi over 6 would be 1 pi, so 7 pi over 6 is that point right there. From our previous investigations, I know that that's negative square root of 3 over 2 and negative 1/2, and I don't have a very good writing right there, but I can use that for what I need. So secant is the reciprocal of cosine. Cosine is negative root 3 over 2. So what's the reciprocal of negative root 3 over 2? It's negative 2 over the square root of 3. And what should I do with that? Go ahead and we know to rationalize that. Multiply by the square root of 3 over the square root of 3. That's going to give me a final solution of negative 2 square root of 3 over 3. That's my answer there. Next problem, cosecant of 3 pi over 4. Again, identify the angle, 3 pi over 4. It's right there. I know that point is negative square root of 2 over 2 and positive square root of 2 over 2. So, cosecant is reciprocal of sine. Sine value would be square root of 2 over 2. So the reciprocal of that would be 2 over the square root of 2. That again needs to be rationalized, as most of these reciprocal functions will need to be. And so I multiply by the square root of 2 over the square root of 2. That gives me on the top 2 root 2. And in the denominator, just the square root of 4 is 2. So I see those 2's cancel out, leaving me with a nice solution of the square root of 2. Problem number 4. And I'm maybe going to run out of room, but we'll see. Cotangent of 5 pi over 6. 5 pi over 6 is right there. Cotangent's going to need the x and the y value, so I know the x value is negative root 3 over 2. The y value is positive 1/2. Cotangent, if you've forgotten, is x divided by y. And let's see, so that means we have negative square root 3 over 2 divided by 1/2. And I need to multiply by the reciprocal of that second value. So negative square root 3 over 2 times 2 over 1. 2's cancel out nicely. I get negative square root 3 over 1. So that's just negative square root 3. Be careful when you're doing that. See how my negative kind of slides a little, maybe too close to that square root. Might want to put a little bit of breathing room between those so it doesn't get mistaken for just part of that radical. To finish up, tangent of 13 pi over 4. This is one where I don't know where 13 pi over 4 is. It's not on the original unit circle we drew, but I can find it pretty easily. So it's 1, counting on the pi over 4 circle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and there's 13. So that point is negative square root 2 over 2, negative square root 2 over 2, and tangent I know is the y divided by the x. Well, in this case, the y and the x are the same value. They're both negative square root 2 over 2, and I know I can hardly see that by the way I'm drawing it, but they're the same values, so y divided by x, anything divided by itself, is simply 1. Again, since those are both exactly the same, divide them by themselves, that's just a 1 for my solution there. So that works out really nice for that problem as well. So it takes about 5 minutes or so to do those problems, and I wouldn't expect much more time to be required.